As all we know, aviation industry is one of the main contributors to global warming. It contributes to climate change through the emission of carbon dioxide, CO2, as a greenhouse gas, and other non-CO2 forcing agents, such as contrails, the most visible one. These are line-shaped clouds that form behind aircraft at high altitude. This is what we always see in the sky. The aviation-induced non-CO2 climate effects highly depend on the time and location of emission. So it's possible to identify areas of airspace where aircraft emissions have large climate effects and integrate such information into a flight planning tool in order to avoid climate-sensitive areas and mitigate the corresponding effects. Since this measure is related with flight planning, it is feasible with the current ATM infrastructure, so it can be considered as a relatively immediate solution compared to other mitigation measures such as advancing toward fuel-efficient aircraft or using alternative fuels. However, there are several challenges with this measure, and the most important one, in my opinion, and which is the line of my research, is the existence of uncertainty in estimating the climate effects of non-CO2 forcing agents, in particular contrails and nitrogen oxide emission induced effects. If we reroute aircraft trajectory to avoid climate-sensitive areas, we are deviating from cost-optimal trajectories, meaning that we are flying longer, burning more fuel, emitting higher CO2, and if the flight planning is based on unreliable prediction of climate-sensitive areas, in addition to not mitigating climate effects, we are increasing the operational cost, which is the main interest of aviation stakeholders. So we need to increase the confidence level of climate-optimized trajectories. This research activity is linked to two European projects, FOE-CLIM and REFMAP. The idea is to identify sources of uncertainty affecting the estimation of non-CO2 climate effects and incorporate such information into the flight planning tool and try to deliver a climate-optimized trajectory with reduced sensitivity to sources of uncertainty, in particular weather forecast and multiple climate impact estimation model. In this respect, in the Aircraft Operation Lab, we have developed several open source flight planning tools and have taken a leading role in advancing this area of research. In order to incentivize aviation stakeholders taking a step toward implementation, we are doing some large-scale analysis of the mitigation potential, the feasibility, the existing trade-offs, such as the number of flights we need to reroute each day, or the increase in the operational cost. This is something that we believe is missing in the literature, and this is the current focus of our research. I'm so happy to be part of initiatives addressing the global concern of climate change and hope all the industries together can address this challenge.